Hello everyone, I'm your new friend Ruijie, and you tuned into Ruijie Networks channel. I'm here to share some easy-to-understand knowledge about networks. Ruijie launched the next generation Wi-Fi 7 access point last year. Recently, Wi-Fi 7 has sparked heated discussions. Wi-Fi 6 delivers a theoretical peak data rate of 9.6 gigabit per second, while Wi-Fi 7 takes it up a notch with a staggering 23.06 gigabit per second. A direct 2.4-fold increase is an enormous leap forward. Wait, really? You might be wondering, I've heard that Wi-Fi 7 is ready to have a maximum data rate of 46.12 gigabit per second, which is 4.8 times that of Wi-Fi 6. Are you sure about 23.06 gigabit per second? So, which one is correct? Well, let me clarify in detail. If you stumbled upon this video, you are in for a treat. Today, I will elaborate how this peak rate is calculated and dive into some technical features. First, let me introduce the calculation formula for the peak data rate. Don't forget to hit that like button and save this video for later. Let's move on. Wi-Fi peak data rate equals encoding scheme times cooling rate times number of valid subcarriers on the maximum channel times the number of symbol transmissions per unit time times number of spatial streams. Well, the first factor of this formula is the encoding scheme. In wireless communication, data travels through electromagnetic waves. The encoding scheme is a modulation technology that utilizes various combinations of amplitudes, phase, or frequencies of radio waves to represent data information. The encoding scheme determines the number of bits that can be carried in a symbol. Wi-Fi 7 adopts 4K QAM, allowing each symbol to carry 12 bits of information. In contrast, Wi-Fi 6 uses 1K QAM, so that each modulation symbol carries 10 bits. The encoding capacity of Wi-Fi 7 is 1.2 times that of Wi-Fi 6, enabling higher information density and efficiency. Wi-Fi communication can be compared to an express delivery service where goods are transported between APs and stations using WANs. Channels and subcarriers are like links with different weights. A symbol indicates a WAN, while the data information represents the goods to be transported. Each one in Wi-Fi 6 can deliver 10 bit data, whereas in Wi-Fi 7, amount indicates to 12 bits per WAN. And next, let's explore the second factor in the formula, cooling rate. During data transmission, most of the 12 bits are utilized for sending valid information, with the symbol portion reserved for error correction. The cooling rate refers to the ratio of the actually transmitted data bits to the theoretical value. For both Wi-Fi 6 and Wi-Fi 7, the maximum cooling rate remains at 5.6. Apart from increasing the capacity per WAN, we must widen the links to further enhance transmission efficiency. This leads us to the third factor in the formula, the number of valid subcarriers on the maximum channel. Wi-Fi communication relies on electromagnetic waves as a physical medium and utilizes three frequency bands: 2.4 GHz, 5 GHz, and 6 GHz. The 2.4 GHz band spans from 2,401 MHz to 2483 MHz. The 5 GHz band is divided into 5.2 GHz low-frequency band with a range of 5170 MHz to 5330 MHz, and a 5.8 GHz high-frequency band with a range of 5735 MHz to 5835 MHz. The 6 GHz band ranges from 5925 MHz to 7125 MHz. Taking the 2.4 GHz band as an example, is divided into 13 channels. The channel bandwidth, also known as the frequency width, indicates the frequency range covered by a specific channel. For a clear picture, envision the 2.4 GHz band as a highway. Different lanes represent distinct channels, accommodating varying circles. Channel bandwidth equals to lane width. wider bandwidth enable more vehicles to travel correctly. Each channel has a total width of 22 MHz. However, the available width is 20 MHz. The other 2 MHz is reserved as a guard band to separate agency links and not for data transmission. Channel is further divided into subcarriers. For example, a 20 MHz channel is divided into 256 tones. Tone is the minimum unit in the frequency domain for wireless transmission. Only 234 tones are used for data transmission. They are known as data subcarriers or weighted subcarriers. To enhance the transmission rate, a direct approach is to increase the channel bandwidth. Through the channel bonding technology, two 20 MHz channels can be bonded into a 40 MHz channel, while two 40 MHz channels can be combined into an 80 MHz channel. Due to frequency resource limits, Wi-Fi 6 supports channels with up to 150 MHz bandwidth through channel bonding, including 1,960 subcarriers. With the 6 GHz band at its disposal, Wi-Fi 7 boasts abundant high-quality channel resources. It allows two 160 MHz channels to be bonded into a single 320 MHz channel, containing 3,920 subcarriers. In this way, the number of valid subcarriers on a 320 MHz channel in Wi-Fi 7 is twice as many as that on a 160 MHz channel in Wi-Fi 6. Let's imagine the 160 MHz and 320 MHz channels represent two highways. Wi-Fi 6 enables up to 1,960 ones to run side by side simultaneously on the 160 MHz highway, while Wi-Fi 7 allows a maximum of 3,920 ones to run simultaneously on the 320 MHz highway. And now let's look at the fourth element of the formula, the number of symbol transmissions per unit time. Up to now, we've been examining data transmission in terms of frequency domain. However, there is also a time domain to consider. In time domain, symbol is the transmission unit. To avoid interference between symbols during transmission, a guard interval is set between agency symbols in microseconds. 1 second equals 1 million microseconds. Total symbol transmission time equals single symbol transmission time plus GI. The transmission time of a single symbol remains unchanged at 12.8 milliseconds for both Wi-Fi 6 and Wi-Fi 7. The GI also keeps consistent. When the GI is 0.8 milliseconds, we can derive the above formula, indicating that 73,529 symbols can be transmitted per second. In summary, Wi-Fi 7 delivers the same symbol transmission capability as Wi-Fi 6. There has been no improvement. Take ones as an example. Each row of ones is active within a symbol. On a bonded 320 MHz channel of Wi-Fi 7, there are 3,920 ones can run side by side, one each row, and a total of 33,529 rows that can be active within 1 second. And finally, the fifth factor is number of spatial streams. MU, MI, MO is a wireless communication technology that allows APs and stations to simultaneously use multiple antennas for transmitting and receiving data. MU stands for multi-user, indicating that an AP can communicate with multiple stations simultaneously. Similar to lanes on a highway, one spatial stream is equivalent to a lane from an AP to a station. Wi-Fi 7 provides 8 spatial streams, indicating 8 lanes where the one can carry more traffic. In this case, only one AP is deployed, while there may be multiple stations. A quick note for everyone's attention, you might have heard about Wi-Fi 7 increasing the number of spatial streams to 16 with MU, MI, MO technology. And now, some of you might be thinking, oh, wait, did you make a mistake? Did I say something wrong? Really? And today, I want to clarify effectively that according to the latest draft 3.1 of the IEEE 802.11 B standard released by the Wi-Fi 7 Working Group of the Wi-Fi Alliance in 2023. Wi-Fi 7 supports up to 8 spatial streams. The number of spatial streams remains unchanged compared with Wi-Fi 6. And now, with all these 5 elements in place, we can finally calculate the peak rate. Wi-Fi 7 peak data rate equals encoding scheme times coding rate times number of valid subcarriers on the maximum channel times the number of symbol transmissions per unit time times number of spatial streams, and that is 12 times 56, 12, 3,920 times 73,529 times 8, and that is 23.06 gigabits per second. Based on the preceding calculation and analysis, we can draw 3 calculations. Number 1, the theoretical peak rate of Wi-Fi 7 can reach up to 23.06 gigabits per second. And number 2, compared with the theoretical peak rate of Wi-Fi 6 at 9.6 gigabits per second, the theoretical peak rate of Wi-Fi 7 is 2.4 times that of Wi-Fi 6. And number 3, the 2.4-fold increase in the data rate is attributed to 2 factors, including scheme and the number of valid subcarriers on the maximum channel. And now I want to clear up your initial confusion. Is that the peak rate of Wi-Fi 7 can reach 46.12 gigabits per second, which is 4.8 times that of Wi-Fi 6. However, the information is outdated and the date is incorrect. Take my word for it. Well, the theory may sound abstract. High-speed connectivity plays a vital role in various aspects of our daily lives. And during weekdays, we rely on fast network speeds for large-scale downloading and seamless remote work. After work, we have zero tolerance for gaming latency or video freezing. Even on weekends, when we find ourselves in crowded places like parks, stadiums, or malls, we still experience smooth network experience. In other words, Wi-Fi 7 is crucial for seamless connectivity throughout the entire week. If you have any insights or would like to learn more about Wi-Fi 7, please leave comments and give this video a thumbs up. And don't forget to subscribe to our channel to stay tuned for further updates. In our next video, we will continue to explore the other key technology of Wi-Fi 7. Thank you for watching this video, and goodbye for now.